Hello everyone, welcome back to my channel Learn Math with me. Today in this video I am going to explain exercise 5.1 of continuity and differentiability. So before starting this video, please like, share and subscribe my channel, and don't forget to hit the bell button given below to get the latest updates of my video. So here is the first question. Let me read the question. Prove that f of x is equals to 5x minus 3 is continuous at x equals to 0, x equals to minus 3 and x equals to 5. Here one function is given. For this we have to check whether the given function is continuous or not at x equals to 0, x equal to minus 3 and x equals to 5. So first let's check whether f of x is continuous at x equals to 0 or not. F is continuous if limit x extends to 0, f of x is equal to f of 0. So let's apply the limits first. Limit x extends to 0, f of x equals to limit x extends to 0. Here f of x is 5x minus 3. Now put 0 at x. 5 zeros are 0 minus 3. 0 minus 3 is minus 3. Now take if x equal to 0, then f of 0. Put 0 in the place of x. 5 into 0 minus 3. 5 zeros are 0 minus 3. Minus 3. So now limit x extends to 0, f of x is equal to f of 0. Therefore f is continuous at x equals to 0. Now let's check the continuity at x equal to minus 3. Even here same, if limit x extends to minus 3 is equal to f of minus 3, then f is continuous at minus 3. First let's take the limits. Okay, limit x extends to minus 3, f of x. Here f of x is 5x minus 3. Put minus 3. 5 into minus 3 is 5 into minus 3 is minus 15. Minus 3. Add up. Minus 15 minus 3 is minus 18. Now when x equal to minus 3, put minus 3 in the place of 5x minus 3. So 5 into minus 3 minus 3. 5 into minus 3 is minus 15 minus 3. Add up. Minus 15 minus 3 is minus 18. As limit x extends to minus 3, f of x is equals to f of minus 3 equal to minus 18. Minus 18, even here minus 18. Both limit x extends to minus 3, f of x is equal to f of minus 3. Therefore f is continuous at x equals to minus 3. Now let's check whether the given function is continuous at x equal to 5 or not. For that let's apply the limits first. Limit x extends to 5, f of x. Here f of x is 5x minus 5, right? Now put 5 in the place of x. 5 into 5 is 25. 25 minus 3, 22. Now take x equal to 5. Then f of 5. Put 5 in the place of x. 5 into 5, 25. Minus 3, 22. Now see, limit x extends to 5, f of x is equal to f of 5. So therefore f is continuous at x equal to 5. Now let's move to the second question. Let me read the question. Examine the continuity of the function f of x to x square minus 1 at x equal to 3. Here we need to find the continuity of f of x. 2x square minus 1 at x equal to 3. If limit x extends to 3, f of x is equal to f of 3, then it is continuous. Okay. Let us apply the limits first. Limit x extends to 3, f of x, limit extends to 3. Here f of x is 2x square minus 1. Now put 3 in the place of x. 2, 3 into 3 square minus 1. 3 square is 9. 2 into 9 minus 1. 18 minus 1 is 17. Right. Now take x equal to 3. F of 3. Now put 3 in the place of x. 2, 3 into 3 square minus 1. 3 square is 9. 2 into 9 minus 1. 2 into 9 is 18 minus 1. 18 minus 1 is 17. Okay. Now limit x extends to 3, f of x is equal to f of 3. So f is Now let me read the third question. Examine the following function for continuity. In that first is f of x is equal to x minus 5. Now here also we need to check the continuity. Here no number is given to check the continuity. So assume c be any real number. Now we need to check limit x extends to c, f of x is equal to f of c or not. Now let's apply the limits first. Limit x extends to c, f of x is equal to limit extends to c, f of x is x minus 5. Now put c. Okay, c minus 5. Now if x is equal to c, then f of c, put c in the place of x, c minus 5. Now see both. Limit extends to c, f of x is equal to f of c. Therefore the given function f is continuous at every real number. Second sub question. F of x is equal to 1 over x minus 5, where x is not equal to 5. Now let c be any real number except 5. Why except 5? Because when I put 5 in the place of x, 5 minus 5 becomes 0. So this is undefined. Right. So we shouldn't take 5 here. So therefore x is not equal to 5. Now let's check whether limit extends to c, f of x is equal to f of c or not. Let's apply the limits first. Limit x extends to c, f of x is equal to limit x tends to c, where f of x is 1 over x minus 5. Now put c, 1 over c minus 5. Now if x is equal to c, then f of c equals to 1 over c minus 5. See here both. Limit extends to c, f of x is equal to f of c. Therefore f is continuous at every real number except 5. Now let's move to the third sub question. F of x equals to x square minus 25 over x plus 5, where x is not equal to minus 5. Here also same. If I take minus 5 in the place of x, 5 I get cancelled. 0 will be the denominator. So it becomes undefined. So therefore we shouldn't take minus 5. X should not be equal to minus 5. See, we can write 25 as 5 square, right? So x square minus 5 square over x plus 5. See here, x square minus 5 square is in the form of a square minus b square, right? A square minus b square is a plus b into a minus b. Here a is x, b is 5. So x plus 5, x minus 5 we got, right here. X minus 5, x plus 5. X plus 5, x plus 5 get cancelled, remaining x minus 5. So x minus 5 is a polynomial function. We know that every polynomial function is continuous. We already studied that, right? You can check my videos to understand this. F is continuous. Okay. Now let's move to the fourth sub question. F of x is equal to mod x minus 5. As you all know, every modulus function is continuous function. Therefore, f is continuous. The given function f of x mod x minus 5 is continuous. Now, fifth question. Let me read the question. If the function f defined by f of x, if x less than or equal to 1, 5, if x greater than 1, okay, is continuous at x equals to 0, x equal to 1 and x equal to 2. Now here for the given function we need to check whether the given function is continuous or not at x equals to 0, x equal to 1 and x equal to 2. First, let's check at x equal to 0. Here, if LHL, left hand limit, is equal to the right hand limit, then f is continuous. Now, let's take left hand limit first. Left hand limit means 0 minus. Limit x extends to 0 minus f of x. 0 minus means somewhat less than 0. Okay, somewhat less than 0. Where we are getting less than 0? See, in the first condition, x less than or equal to 1 means equal to 1 and also less than 1. Less than 1 means 1, 0, minus 1, minus this side 1 and less than 1. So 0 minus somewhat less than. So this side, right? So we can apply the first function. So f of x is x. Okay. Now put 0. Now let's take right hand limit. Limit x extends to 0 plus. Even here we can't take second condition because 0 plus means the number should be little, somewhat greater than 0. See, in the first condition itself we will get this 0 plus somewhat greater than x less than or equal to 1, 1, 0, minus 1. Somewhat greater than 0 means first function we take, right? So f of x, put 0 in the place of x, so 0. Now left hand limit is equal to the right hand limit, therefore f is continuous. Now let's check for x equal to 1. At x equal to 1 means, let's take left hand limit. Let's apply the limits. Limit x extends to 1 minus f of x. 1 minus means what? Somewhat less than 1, right? Less than 1 means which function? First function. Less than 1, this side. X less than or equal to 1, this function. So x. Okay. Limit x extends to 1 minus x. So put 1. Now let's take right hand limit. Limit x extends to 1 plus means this side. Somewhat it is little greater than 1. Okay. Greater than 1 means we take second condition. X greater than 1 means 2, 3, 4, 5, right? So x greater than 1, 1 plus above 1. So we have to take second function. Limit x extends to 1 plus 5. So 5. Here left hand limit is not equal to the right hand limit. Therefore f is discontinuous at x equal to 1. Now let's check the continuity for x equal to 2. Let's take the left hand limit. Limit x extends to 2 minus. Means 2 minus means 2 less than 2. Somewhat less than 2 means second condition. Limit extends to 2 minus second function we have to take, that is 5. Right. So left hand limit is 5. Right hand limit x extends to 2 plus means greater than 2. This is also second function, belongs to second function. Therefore limit extends to 2 plus is 5. So 5. Left hand limit is equal to the right hand limit. Therefore f is continuous at x equals to 2. So today in this video I have explained some questions of exercise 5.1. Hope you all are clear with this topic. If you have any doubt, let me know in the comment section. In the next video, let us discuss some more problems of exercise 5.1.